In this video, I'll talk about the Java persistence query language and criteria queries. By using the JPA Entity Manager and relationships, you can do most simple transactional processing. For example, in a simple social network application, you could find a person by their primary key, get a list of all their received messages, and then retrieve those message details by looking at the fields of those messages. But now, imagine if a person could have thousands of messages, but you only wanted to show messages received in the last 7 days. How could you handle it? With JPA, you could retrieve all messages and then check the date to see if it was less than 7 days ago. And this would work, but it's very inefficient. It involves retrieving every message from the database, loading it into memory, and then discarding it if it's too old. If you have thousands of old messages, then they're all going to be read into memory and checked, even if only one was received this week. If JPA has access to a full relational database, it would be crazy to require this kind of searching to be done manually in Java code. So instead, JPA provides an ability to write queries that are efficiently processed by the database. And this is what the Java Persistence Query Language, or JPQL, is used for. The reason that JPA uses JPQL instead of SQL is that your object-oriented model can differ from your relational model. The default mapping between the two could be overridden in annotations or in XML configuration files that might be changed. JPQL lets you write queries in terms of the entities in your project, and those JPQL entities get mapped into the corresponding names used into the database. So the JPQL gets mapped into the correct SQL. Fortunately though, you don't need to learn an entirely new language. JPQL is basically the same as SQL. Here's an example. In fact, this is an example of a parameterized query. The query finds all messages with a date greater than the parameter called date. Remember that in JDBC, parameters are supplied using question marks. JPQL is slightly different in that parameters are given using a colon and then the parameter name. To store the query, you just store it as a string and then call createQuery on the JPA Entity Manager. That last parameter to create query tells Java the type of entity that's expected to be returned from the query. That parameter is then set by name. So here we're setting the date to be the value of the local variable named cutoff that happens to be an instance of the date class. You could pass any parameter that matches the types of the query. In the last line, we execute the query, and this will return a list of messages. In this example, we've stored the query strings just inside ordinary Java variables. JPA also provides the ability to declare the queries alongside the entities, using what's called a named query. One benefit of a named query is that when you make changes to an entity, you don't have to search through all your code looking for JPQL that needs to be changed. If they're sitting alongside the entity, it's easy to find and fix. And here's how you can declare a query using the named query and an annotation on your entities. When you need to query the database, you don't need to write JPQL code again, you just execute the query by name. If you want to declare more than one query, just use the named queries annotation to collect them all together. So far, I've used getResultList to get a list of all results. If you know there's only one result, then you can retrieve it directly using getSingleResult. JPA also supports paging. You might want to retrieve only some of the results. For example, you could have a user interface that shows 10 results at a time. If the user's on the third page, then they'll only want to see the 31st to 40th result. The JPQL query object lets you specify this using setFirstResult, and that sets the index of the first result you want returned, and then setMaxResults, that specifies how many results in total that should be returned. So that's the essentials of JPQL. JPQL is basically a simplified SQL that works with your entities. JPA automatically translates JPQL into valid SQL to run on the database. With JPA, you don't have to worry about result sets and manually creating entities. JPA looks after all of that completely for you. When you execute a JPQL query, JPA will return entities as Java objects for your application. For the full syntax and capabilities of JPQL, should read the Java Persistence API specifications. Okay, so JPA and JPQL will obviously save you a lot of work and reduce many errors. But if you're like me, you might be a bit nervous about seeing queries written in strings. One of the claimed benefits of object relational mapping is that you're less likely to make mistakes because the compiler can do type checking for you during compilation, rather than having to wait until runtime to discover that you messed up an SQL statement. But if queries are stored in strings, then the compiler isn't able to do these checks for you. Fortunately, JPA offers two solutions to help with this. The first is that when you deploy your application, JPA will actually check the strings in your named query annotations. This means that any errors will be identified the moment you deploy it, during testing or during production. So if you're writing JPQL, it is far more reliable to use named queries than it is to declare the queries in strings inside method bodies. The other solution that JPA offers is something called criteria query. If you need to dynamically create your queries in code, then instead of typing JPQL in strings, you could, or rather you should, use criteria query to build up JPQL using methods. Here's an example of what it looks like. It is a bit more complex than just writing SQL or JPQL in a string, but this complexity helps ensure that there's type safety at compile time. Let's step through it. First, it creates an empty criteria query, specifying that the return result will be of type message. Then it identifies the root. This is the source of records used for the query. Basically, each table you would list in a from clause of an SQL query would be a root in criteria query. It then specifies that the result should be those items retrieved from the root, that is, from the message entity. And the last part is the where clause. It restricts the returned entities to those with a date greater than the local variable called cutoff. The class with an underscore is a metamodel class. You don't need to write those classes yourself. They're created using an annotation processor that scans through your entities and generates Java source code for the metamodel classes. If you're using an IDE such as NetBeans, you don't have to worry about how this is done because NetBeans automatically runs the annotation processor for you. If you're using something else, then you'll need to configure your build process to call the annotation processor. Anyway, the point of a metamodel class is that it allows you to statically refer to fields or properties. Even though date is a private instance variable of the message class, in the metamodel it is a public static field, so you can refer to it in code when you're writing criteria queries. To sum up, if you're using JPA, then JPQL provides most of the functionality of SQL, so you can write efficient queries that access the database. I've offered a very superficial coverage of JPQL because it is fairly intuitive to read, and the best way to pick it up quickly is to look at a lot of examples. If you're not sure how to do something in JPQL, then just search for an example that does something similar, and modify the code to match your tables and entities. In this video, I've looked at JPQL, named queries, and criteria queries. I would suggest that named queries are probably the most readable, and they have the advantage that even though they're embedded in strings, they are automatically checked for correctness at deployment. So if you're not sure what to use, I would probably work with named queries. The criteria API makes a lot of sense if you're building dynamic queries that can't be expressed just using parameters. The criteria API is more complex, but it might also be a good choice if you prefer to have your queries alongside the Java code that processes the results. The criteria API provides all the expressiveness of JPQL while also ensuring type safety, so that if you do modify any entities, you'll get a compile error if you don't also fix up the criteria queries. Which one you use is ultimately a decision you'll have to make for yourself.